Thanks, Piotr. Thanks, Piotr. Hello, everyone. I must say, it's very unusual for me to be here. I never was here. But okay, let's start. Today, I'd like to talk about API management. In the meeting agenda, it was about API. It was a bit enigmatic, and I'd like to try to explain what's going on. 2 months ago, I did the presentation about designing APIs, and the topic of managing APIs, that is handling basically the whole life cycle of an API until it's retiring, didn't fit into that presentation. So I decided, well, let's talk about it in a separate meeting. So now it is. This time has come. Let's suppose you created an API, web API, new Shiny. You have version 0.1. You deployed it in production, and you're happy. You celebrate. And what next? Because it's very unusual case that the API will not change. Yeah, if it is a product that will be used, most probably it will have to change to user needs, and then you will usually start to think, oh, okay, how can I introduce these changes? Who in principle can introduce these changes, when, and how we can communicate these changes to our users? Yeah, the more users, the more complicated this communication is. How we can ensure that our API is used as we expect, that no one is breaking the rules we impose, and how can we be sure that our API works and works in a performant way? So these are usual questions. And to answer these questions, you need a process. Seems that you need a process that is a kind of set of rules that help you to keep these things organized and keep going. And this process is called API management. This is an organization-specific process. There are some basic, commonly agreed best practices, but in most, this process is specific to each organization, and it defines how to create, update, and publish new versions of APIs. How to ensure that, how to look for security, and for analytics, monitoring, and logging. I'd like to talk about each of these areas, that is change management, security, infrastructure, monitoring, and analytics, one by one, with emphasis on the change management. Because I'm a developer, I'm a front-end architect in Fresha. I'm not an expert. I do not count myself as an expert in security and not in DevOps. Therefore, monitoring, statistics, and security, I will talk about these areas quite short. Okay, so here you see a typical life cycle of an API. So it's all everything basically starts with planning. Then you sit and start to code, then test, deploy, and what then? Then usually comes next idea, which gives this cycle of planning, coding, testing, and deploying once and again, until we decide, okay, it's we have a totally another idea how to do this stuff, how to implement, how to add value to our customers. So we should retire this API. And what usually lifetime of an API is maybe several years. And within these several years, there can be hundreds of updates, hundreds of changes in the API. How can we communicate? How can we distinguish that how can we find which set of API, which functionality of an API is currently available. So first thing that comes to our mind is versioning. Yeah, we use versioning practically everywhere. We use versioning for desktop applications, for example, for Git, because to mark our changes, because Git hashes are kind of versions. Yeah, can be treated like versions. And when it comes to API, there are two main strategies to handle these changes and to identify these changes. And it depends where we can maintain several independent instances of our API, or we do not want to do this. If we agree and that it's better for our organization to have only one, that is current version of our API in production, yeah, and we can evolve it continuously. It's okay. Let's call it a non-version API. It has some pros and cons. I will talk about it 2 minutes. And the other one, when we rather want to mark this, like kind of go in steps. So this was step 1. This was step 2. This functionality is available on step 1, but not on step 2, or vice versa. Yeah? And this is called versioned API approach. Non-versioned API. For example, we at Fresha use this approach. We deploy for all our internal APIs, and my opinion is for internal APIs it's okay if we can guarantee the two conditions that every developer, every team, every development team follows the no breaking changes strategy. What does it mean? That we try to evolve, to make changes in the API, so clients can do not need to break. Yeah. So they work all the time. From time to time, of course, they have to adapt, but before the actual change in the API happens, but not afterwards. And that's why they work. And the second condition is it's almost always a must to be able to closely cooperate with all clients. If it is a private API, clients mean developers, most often front-end developers within your organization. If you know all of them, if you can gather them and say, okay, tomorrow we will introduce this change, it's okay. Yeah, then it's easier to follow this non-versioned approach, because it's only one instance of this API in production. Infrastructure is simpler, monitoring is simple, rollback. For example, if something bad happens, you can easily roll back the whole platform to the previous stable version. We at Fresha use develop REST APIs, but another prominent advocate of this approach is GraphQL. Yeah, they say that okay, it's much better to have one endpoint, do not version it, and just to evolve. When you need something new, to just add it. When you know that no one uses the functionality, just remove it. Yeah, but what if I really want to version my API? Yeah, so this most often it happens for public APIs where you do not even know all your clients. Then in principle you have much more control over what you can put in a new version of an API, but you have also a big more responsibility. Responsibility, I mean that you must in advance inform your clients, then hey, once in a quarter or once in a year, we will update API. We'll most probably issue a new major version with some breaking changes. It will be available for next year, and within after a year, the old version will stop to work. So you have basically 1 year to adapt. But this, I mean, having more control over when you can retire, when you can introduce new changes. But using versioning APIs, you can maintain several separate versions, multiple versions of the API more easily, because you just deploy deploy several versions and route. Configure your API gateway so that it routes by path to give it instance. And because of this, it's easier to support legacy clients. Yeah, because you may have one instance of your API with the old version running somewhere. And all legacy clients, you know that they will hit they will call this instance, yeah. So it can be made simpler, for example. And again, my opinion is this versioning is almost always a good thing, or is almost always a must for public APIs, because there you do not have control over who your clients are. How to implement versioning? There are basically five approaches to building APIs. That is resource-based, that is REST. Event-based, that is something like WebSockets. Query-based, that is GraphQL. What are two? RPC-based, yeah, that is SOAP and RPC. For most of them, except for example, maybe query-based, the versioning may be implemented, can be implemented in 4 ways: by using version numbers in the URL path, and this is the simplest and the most popular way; by using query string parameters; by using content negotiation feature. I have never seen something like this where the place where it was used, and the heteros linking, that is when you pass actual URLs, the valid URLs to your newest version inside the response body. For me, personally, it's not that important which way you will implement the versioning. The most important is the consistency. So it's the user will not be surprised that okay, here it's path based, here it's content negotiation. The more consistency, the better. Now let's come and talk about breaking changes. I mean, most of changes in the API. How to say? They will require our clients to adapt. Otherwise, the client software will break or stop working, unless we made some precautions. Basically, if anything that exists in your API, that is resources, endpoints, media types, queries, mutations in GraphQL, change the semantic, it means that your API introduced a breaking change, and the clients must update. So here are examples of such breaking changes. Basically everything except changing something from being required to being optional and adding new optional things are breaking changes. Therefore, we should think about how we introduce this type of changes, and possibly how we can avoid them. How we introduce and communicate, that's I mean pretty much standard. We just deploy a new version, a new API version with the major version increased. Yeah. But when it comes to how to avoid these changes, the one general approach is just to make new things, new functionality optional. So when clients knows how to use them, how to use this new functionality, just can pass extra parameter and will get access to it. But by default, the API does not use this new functionality, which that introduced these breaking changes. What helps is maintaining an API schema, possibly coupled with having API gateway, the third-party software. What also helps is hiding these implementation details and SDKs. So SDK act as a extra layer of indirection that can, because you provide SDKs and you know how this API changed, so you can hide this change in the SDK internals, and clients will not have to update. You can of course define extension points explicitly that are, for example, reserved fields that are some bags for future use. You say that this parameter is an object which in the future will be populated with new fields. Yeah, for now it's empty, but in the future we'll add something here. What is also important is that we should not really we shouldn't really encourage our clients to do some strict schema checking, because every change then will be a breaking change. This is also personal opinion, that using enums in Web API, strict enums, is almost always a bad thing, and it gives more problems than it solves. What is also extremely important, from my point of view, is having a set of compatibility tests. So when you would like to introduce a new feature, you can run this feature against this compatibility test set, and then if you have some unwanted breaking change, you will spot them. So when this is all when it comes to change management. And now very shortly, let's talk about API security. As I said, I do not count myself an expert in security, therefore this section will be very, very short. To protect something, you need what to protect. And this means you need to first make an inventory of your APIs. Yeah, there are software, API gateways that help with this task. Second, you should architect your APIs with using the principle of least privilege. That is, the services that implement these APIs should have minimum amount of access of permissions, just enough to do they work and not more. Because otherwise, something in the future, maybe something happen that can happen that will make some malicious user be able to exploit these extra privileges and just remove some important part of the database, or break into our private network or something like that. Authentication is very important for most APIs. Again, my personal opinion, don't do this by yourselves. Use third-party services, because it's much faster and it's much more stable, I would say. Yeah. Almost always HTTPS and TLS encryption is good. And usual probably some trivial stuff is we shouldn't trust anything from the internet. We should sanitize and validate this input. Yeah, every time, no exceptions. And if needed, we should again using the third-party software, probably not inside our applications. We should should be able to use, to limit the amount of requests that come from given, for example, from given user. Yeah, this can prevent or at least limit the amount of requests, and that is data which can be extracted by a malicious user. And the last part is login, monitoring, and analytics. Again, this is parts which this is area for which there are many good, very good third-party services. So my advice: do not do it by yourself. Use them, integrate with this with existing platforms. In Fresha, we use Datadog and Sentry. Basically, privately, I also used Google Cloud Monitoring and CloudWatch from AWS. But these two, that is Datadog and Sentry, I can wholeheartedly recommend. If you will Google API monitoring, you will find a host of articles of comparisons of existing solutions, free, paid, and so, for any basically for any purpose. So when you choose the platform you want to integrate, just do it. Don't do it by yourselves, and then start to monitor and give some. Collect some statistics, and based on these statistics, maybe do some changes for the future. Yeah? Scale, for example, based on the amount of requests for a given endpoint, you can make the decision where you should probably scale this part of the service more or less. Yeah, or you can just decide, okay, this part is not used anymore, so we can just retire it. This is all from my from my side. Thank you. So maybe now it's time for questions.
Thank you very much, Adri. Adri is from Freshhouse, our sponsor today. So thank you very much also for sponsoring this event. And is there any question? Is there any question from the room? Yes, there is one.
Hello, I have one quick question. Should a versioned API work per whole API or just per one endpoint? So should it be possible to, for example, for one client to work with two versions of API at the same time?
I think usual answer, it depends. It depends how much. If you can guarantee that most of your API will not contain breaking changes, that it's, in my opinion, it's okay to have versions only in one place. That is in one endpoint or a small set of endpoints. But usually this is not the case. I would say.
Okay, so other questions? I can't see any questions on YouTube. So I have a rhetoric question. How about not using Datadog, but using Sumo Logic for logs?
Very good question. Maybe we can talk about this after workshop, and you will show me what Sumo Logic can do.
Okay.
How it can help.
All right. So thank you very much.
Thank you again.